Hey you guys, welcome back to the channel PHYSICSSIRJEE, and here we are in AITS Select series, and actually this is a follow-up video to one of the resolved series situations where I have discussed already the topic of dependent errors and how students falter to recognize them in exam situations. So at the end of that video, whose link you can find in the description below, I have given a practice problem to apply the concept that I have already taught in that particular video. So dependent errors, we are looking at output machine, which is very familiar situation. It's not about solving output machine for acceleration. It's about estimating the error percentage in the calculated acceleration in a standard output machine situation. Okay, so let's go ahead and look at the formal wording of the question. Okay, so this was already presented to you, and in case you are new to the channel, so let's go ahead. You want to do it on your own, just pause the video here, have the fair try, and then come back to the solution that I'm going to explain. Okay, so in Atwood's machine setup, the data is given by M1 is equal to 103.5 plus or minus 0.2 grams, and M2 is equal to 43.5 plus or minus 0.2 grams. That means someone has estimated them with some error. Are the masses of the two blocks shown, and the value of G also has an error in measurement, which is 10.00 plus or minus 0.01 meter per second square. Some small printing error here. Okay, is the acceleration due to gravity. The maximum percentage error in the calculation of acceleration of blocks is, if it is equal to 1 minus x by 30%, then find the value of x is the request. Okay, right? So pause, try it out, and then move forward. So before we actually are going to look at the solution, I keep reiterating there is already a resolved video series in which this was the latest video I think I have taken up, and the link of which is in the description below or in the I button above. So please make sure you go through those two illustrations and the concept that I have explained in that, and then come back to understand the solution that I am going to take up here. Okay, right. So let's move forward. You know the basic calculations about the Atwood machine. So if you are passing 11th or 12th standard, I think this is a very simple concept for you to understand. So you can go ahead and look at the left side of the screen to check out the explanation. So finally, after calculating, if M2 is the heavier mass, I have reversed M1 and M2, it doesn't matter actually from the question. So if M2 is the heavier mass and M1 is the lighter mass, the imbalance in the weight would be M2 minus M1, and the total inertia of the system which is supposed to be moved is M1 plus M2. So this gives you a very simple a value of acceleration that you need to measure. Okay, now the values of M2 and M1 order not important. I have written down from the question here. The subtraction is 60 and the addition is 147. I define a quantity called M2 minus M1 by M2 plus M1 as some P. There's a new quantity that I'm going to look at. Okay, and therefore A value should be equal to P times G. So I would try to estimate the error in P and error in G separately, and then estimate the error in A. The reason why I want to look at P is not an ordinary kind of a function that you have. It has M2 and M1 in a slightly difficult manner in which we have to estimate the error. Okay, so in numerator and denominator, they are dependent on each other. This is where the understanding of dependent errors comes into picture. You can't just take numerator and denominator and use the old rule where we have for independent errors. Okay, so that's the reason why I'm going to first solve for P's error, and then we'll plug in the G to get the value of A. Okay, so once the basic calculations are done, we'll move on. So I've just put P is equal to this and I've rearranged it. The reason for not writing this one and writing this one is, now you could claim that M2 and M1 were measured in two different experiments. Now on the RHS here, these two are independent of each other, whereas M2 minus M1 as a quantity and M2 plus M1 are dependent on each other. Okay, so that's the reason why I put an effort to rearrange this so that my focus is on the right hand side where I get the independent errors. And this also is slightly difficult, so I rearrange it in this manner. The 1 plus P by 1 minus P, I'll rearrange it in this manner. And as I have taught in the previous video of resolve series, always try to put an effort to get it into differentiation. So the best way is to not follow any rule, just follow the basic principle of errors being small, then use differentiation. So once I differentiate this on both sides, you end up having, this is a pretty simple calculus. Okay, here it should be very important to note that in a normal calculus you get a minus sign when you differentiate a coefficient, right? But you put a plus because these two are independent errors. Already we discussed this in the past video. Okay, so then the percentage error in dp divided by p, I forcibly divide by p and then take the rest of the things that side, you get this red colored thing. And this one I split it up the common denominator this way and substitute all the values of p and m1 and m2, and the dm1 dm2 both were given as 0.2. I can bring this one out. Okay, 0.2 comes out. 1 plus 103.5 divided by 43.5, and you can have an m1 out, that would be a 43.5, and 1 minus p and all these things. When you substitute, you rearrange, you end up getting a simple calculation. So you could see this 147 actually gets cancelled, the square of this, and here also you will have a 147, right? So those that got cancelled, and the calculations look difficult on the first view, but once you manipulate it in this manner, you would end up getting a simple looking answer. This 43.5 and 87 are also easily factorizable, and then you end up getting 1 by 150. So the fractional error in P, now I have estimated. Now I'll plug it into that A is equal to PG that I have written in the previous page. So DA by, now you can claim P and G are independent errors. So you can directly write it in this manner. So DA by A equal to DP by P plus DG by G. So the percentage error is about taking these numbers and multiplying it with 100. I think DG by G in the question was given as 0.01 divided by 10. Okay, and you rearrange, you'll end up getting 1 minus 7 by 30. I'm writing it in the form that is given in the question. So the numerical answer for that particular situation is 1 minus 7 by 30. So the required answer is 7 for this. Okay, so in the last 2 years, if you carefully observe, units and dimension and error analysis have been given a very good weightage in the JEE examination. So please make sure you follow and study the rules that are given in the NCERT before you go into the examination. Okay, so in case you have liked this video, please make sure you go through the rest of the series that are very important, and more than 100 videos on difficult topics, topics which actually are not covered in textbooks in a proper manner, topics which students usually have doubts but don't know whom to ask. All these kind of nitty-gritties have been covered in different varieties of series, whose links of the playlists are in the description below. Please do enjoy them. Try to play them in loop one after another so that you keep getting the concepts evolved. Okay, right? So, and in case you've liked this video, please do like it, because liking a video pushes the YouTube algorithm to ensure that my video is actually getting a better reach with audience, and with better reach you could see the quality of the content in the channel. Then there will be a better chances for subscriptions to take place. Okay, so, and also please do share it directly with your friends in WhatsApp and Telegram groups. It would be great help to my channel. And in case you have not yet subscribed to my channel, I request you to do so, and ask your friends to watch at least 2 or 3 videos. I think I am pretty confident with the content I am providing that they will be definitely liking to subscribe it. Okay, so thank you. See you in the next video.